Today for lesson 2, we are looking at ratios and rates with fractions. And I think what you're gonna see as we look at today's lesson is how much this is like all the stuff that we've done leading up to this point. It ties back into what we did with scale and scale factor. It ties into our proportional relationships that we've been talking so much about. And we're just going to continue that idea as we head into the rest of this unit, Unit 4. So listen for those connections. Remember, we're going to be talking about unit rates, constant and proportionality, proportional relationships, and just keep that going. For our first question, it says a train is traveling at a constant speed, and that's that first clue that I was talking about with proportional relationships. Remember, constant speed, the train's not going to speed up or slow down. It's always traveling at the same rate, the same speed. And it goes 7.5 kilometers in 6 minutes. At this rate, how far does the train go in 1 minute? That 1 minute that it's asking us to find is going to be the train's speed. It's also going to be a unit rate. So we'll take this information here from the problem and get our unit rate for it. Now we could create a proportion where we take our information from the problem. So that's 7.5 kilometers in 6 minutes. And we're going to compare that ratio to our unit rate that we're trying to find, or 1 minute. And we could solve it that way. Most of the time when we had a problem like this, we made a table and we compared time, minutes, to kilometers, and we'd fill in that information that we're given. And then we'd go to find the unit rate. So we would, a couple of things to just refresh your memory about is that unit rate always contained our constant of proportionality in the relationship. So when we find this, our constant of proportionality is going to be that number of kilometers the train travels in 1 minute. Remember, our equation for that was, for a proportional relationship, was y equals k times x. But if we rearrange that equation and we want to find k, our constant of proportionality, we have to do a little division. We have to divide our y value by our x value. Our y value here is 7.5 kilometers. Our x value is 6 minutes. And when we divide those, we get 1.25 kilometers every minute. That's our unit rate. And that was what the question was asking. How far does a train travel in 1 minute? The next question says, how far does a train travel in 100 minutes? Since we have a table, it's going to be pretty easy to just add in that extra information. And now we can increase our unit rate using our constant of proportionality to find how many kilometers in 100 minutes. And we don't even need a calculator for this because multiplying anything times 100 is increasing our value 10 times and another 10 times, or 2 place values in our base 10 number system. So if my constant of proportionality here is 1.25, if I get 10 times bigger, it becomes 12.5, and another 10 times, it'll be 125. That's where I have increased 2 times 10 twice. That's 100. 10 times 10 is 100, and that has increased the value of our constant of proportionality 100 times. Let's look at the next one. Lynn ran 2 3/4 miles in 2/5 of an hour. Noah ran 8 2/3 miles in 4/3 of an hour. What are some questions you have or can create about the above statement? So we're given that information for Lynn here. We're given the information for Noah here. What are some questions that you have? Well, they're running a race. We're comparing running speeds. So Maybe a question that you might have is who won the race or who's running faster? Those would be two very good questions. Um, you could ask yourself if, because we don't know how long the race is, so we could ask ourselves, how long is the race? Because if they are running different distances, we don't know if they got to the end of the race or not. Um, but we do know that they've run for a certain amount of hours. Now we're going to do this question a little bit different because what we're going to do after talking about these questions is pick one of the questions that was displayed and solve with the teacher. Now I would actually, on your handout, I believe it says something different, but you're going to solve that question um, on your own. So that's what I want you to do right now. I want you to pick a question and let's maybe narrow it down to a few questions. So we could be asking ourselves, what is their speed? We could be asking, who's faster? Um, we could ask, how far will they run in 1 hour? Or we could ask one more question here. How long to run 1 mile? All right, we're going to leave it at those 4 questions. What I want you to do is pick one of those questions and solve for both Lynn and Noah. Then what we're going to do is take a little time and share our answers and see if you can determine which of these questions was answered. So in the class, share out your answer of whatever you find, and then let someone near you try to decide where you calculated what their speed was, who's faster, and or one of these 2 questions here, so on. All right. Then we'll come back with the rest of the video in the next example. All right, finally, we have a question that says, whose orange juice mixture tastes stronger? Explain or show your reasoning. So let's quickly think about that. If it tastes stronger, and I'm looking here at the mixes for Claire and Han, well, they're combining water with orange juice concentrate. So that thick, usually kind of frozen mixture of the orange juice concentrate. So if we're looking for a mixture that tastes stronger, do we want a recipe that has more water and less concentrate, or the opposite, less water and more concentrate? Well, hopefully you're thinking we want less water. The term watered down comes to mind here. So we don't want to water down the orange juice. We want more orange juice concentrate so it tastes stronger. So let's look at Claire. Claire mixes 2.5 cups of water with 1/3 cup of concentrate. Han mixes 1 2/3 cups of water with 1/4 cup of orange juice concentrate. Now, this is really hard to tell. It seems like Han used a good bit less water, almost a cup less water than Claire. But then he also used less concentrate than Claire did. So this is kind of tough. The best way to compare this is to come up with a unit rate. We want to know how much water is going in to the mixture for each cup of concentrate. Or we could do it the other way around. How much concentrate is going in for 1 cup of water? It really makes no difference as long as we calculate the same thing for both of them. All right, so let's take, we could do a proportion again, but I kind of like the idea of the table. We're going to have 2 tables because we have 2 different mixtures here. So we have Claire and Han. And here's where we need to decide, do we want to determine how much water for 1 cup of juice or how much juice for 1 cup of water? So let's do, how how much water for 1 cup of juice. So we'll put water in the Y column here, and we'll put OJ, juice, in the X column here, so that we'll divide water by orange juice. That's going to tell us a unit rate for how much water goes in for 1 cup of OJ mixture, 1 cup of juice mixture. All right, and we're going to do the same for Han because we have to have a comparable unit rate here. We don't want to mix this up. And then we'll just fill it in. So Claire had 2.5 cups of water and 1/3 cup of OJ. Han had 1 2/3 cup of water and 1/4 cup of OJ. Okay? Don't be intimidated by fractions. Fractions are just numbers. This would look a lot less intimidating probably if these were decimals, because it's just easier to type into a calculator. But don't forget you have that Desmos calculator that lets you put in fractions and mixed numbers, and you can just do the calculation in the same way. So remember, to get our constant of proportionality, our unit rate, we're going to divide y by x. Let's divide the amount of water by the amount of orange juice to find out, for 1 cup of orange juice, how much water is added to the mixture. So if we take Claire's and divide her ratio, 2 1/2 divided by 1/3, we would get 7.5 cups of water for every 1 cup of OJ. If we do the same for Hans, we'll take 1 2/3 cup water divided by 1/4 cup of OJ. We get 6.6 repeating, or 2/3, and that's water. We'll do it as a decimal just to help compare this to this, but leaving those as fractions, of course, would be fine. And now we really need to think about this problem. So let's go back to the question we're answering. We're asked which orange juice mixture tastes stronger. Remember, that means we want less water in the mixture, so it's not as watered down. The person with the least amount of water, since they're putting in the same amount of concentrate here in our unit rate, they're adding 1 cup of orange juice concentrate. Hans is adding less water, so his mixture will taste stronger. Hans will have the stronger mixture. All right. Now, on your packet sheet on the back, there's some more practice going off of what we did yesterday, and that was converting. So go back to that triangle on your sheet where it gave you some pointers of how to go between decimals, fractions, and percentages. And there's just something very quickly that I want to review, and that is rounding. So I have seen a lot of people that still seem to have some trouble with rounding, but most of these questions ask you to round your answer to a certain place. And if you don't round correctly, you're going to get it wrong. So let's take, let's see. Well, so for these examples that I picked here, it says write as a percent. So we're changing these decimal amounts to percentages. And on that triangle tip, it said to multiply by 100. We talked about that yesterday. Multiplying by 100 is just taking the digits in our number and moving them up 2 places larger in their decimal place location. So this 0.452 is going to, all these 3 digits are going to move up 2 spots to 2 larger place values. They're going to be multiplied by 10 and then 10 again to get that times 100. So this answer would be 45.2% if we wrote that as a percentage. The same for, let's see, this one is already rounded to the 10th place. So let's pick one that isn't rounded to the nearest 10th place. I think they're all going to be rounded to the tenths place. So that doesn't really help us with our example. Let's look at something like, let's see, 0.1005. Okay, if we had to write this as a percentage, we multiply by 100, then this would be 10.05%. Okay, now that would technically be wrong because the question said round to the nearest tenths place, and the tenths place is that first decimal point, that first decimal place to the right of the decimal. So here's what we're doing when we're trying to solve something like this. We're looking at a number line here, and on one side, the number is going to be, let me try a different color here. On one side, the number is going to be 10 or 10.0. On the other side, it's going to be 10.1. Those are our two choices. If we're rounding to the tenths place, we can only look at this either staying as it is, staying as a 0, or rounding up to 1, which would be the next closest tenth to that. So then we need to think about this number line, and we need to think, where does this number, this 0.05, fall in between here? So if we were to make some markings, this would be 10.01, 10.02. Okay, I'm not going to make you watch me fill out the whole number line, but if you look, 10.05 would be right there, right in the center of our number line. So our rule for rounding is when we are at least halfway to the next number, that's when we round up. So our halfway point between our 0/10ths and 1/10th, our halfway point is that spot. Anytime a number is on the right of that mark or at that mark, we round up. And in this case, we'd round this number up to 10.1%. But if it fell on this side, we would round down to just 10%. So I'm happy to re-explain that or give you some more examples on Zoom today. If you have any questions about rounding, please be careful about that. Remember your place values. So some ask you to round to the thousandths place. Remember, that's 3 places after the decimal point, to the right of the decimal point. And then there's a few that ask you when you give a fraction to reduce to the lowest terms. That's another word for, or another phrase for saying simplify. So those need to be simplified fractions that you're putting in. But if you have any questions about how to do that, I'm happy to answer them. Just jump on Zoom and take a look at the answer key here at the end of the video. Everybody have a great day.